Okay guys, we're back. This will be our third video. And what I want to do here is let's manipulate some numbers. Okay. Now some of you guys may already have this down, but some of us may need some help with this. So if you don't need this video, you can watch it, and if you don't need it, then it's fine. But for those of you who do, we're gonna take care of that, right? Now, here's a simplified version, guys, of our power wheel, and we don't have any of that other stuff up there. We just got voltage, resistance, and current, okay? Voltage is always on top. We got our line separating it. This right here is resistance. Of course, this is current. And this lets us know, if we look at this will be the formulas that we manipulate to figure out our problems in chapter 3, chapter 4, chapter 5, chapter 6, so on and so on, okay? So here we go. Hang on a second. Let me start my stopwatch. There we go. Can't forget that. Want to observe all union rules. Okay. So let's just go ahead and pick and get these guys again. These numbers mean absolutely nothing to me. And what I'm saying, I'm just picking them right off the top of my head, right? Just to prove a point that you can use any numbers, okay? Any numbers. All right. So let's go ahead and pick a nice voltage value. We'll say let's say 28 volts. Okay, 28 volts. That is our voltage value. And let's see, let's do resistance first. Okay, so for my resistance value, let's say that I have 3.2 k ohms. Okay, now George Simon Ohm, his voltage and current and resistance law, otherwise known as Ohm's law, it dictates to us, guys, if we have two of our variables that we know. We have verified that we have 28 volts in the circuit. We have also verified by a color code that we have 3.2 k ohms of resistance in this one resistor value. Okay, here's what we can do. Here's what I like to do. For that missing variable, I take my thumb and I put right over this I, put right over that current. So the only numbers or the only elements that are visible to me in this power wheel are voltage and resistance. And we have voltage divided by resistance equals current. Okay, so where's my calculator? Here's my calculator, okay? Turn my calculator on, and let's say 28 volts, okay? And we're going to divide that by 3.2, all right? Now, here's the important part, guys. This is going to help a lot of you out. Instead of me saying 3.2000 accounting for all of those powers of 10 up to the kilo position, I'm going to make it easier. I'm going to put my calculator, I'm going to hit this second function. And when I hit that second function, I'm going to come down right above the number 7. It's indicated on our TI-83 with an apostrophe. When you hit that second function, it lets you have access to these guys on top. And that double E right there is telling my calculator, my TI-83 Plus, that I want all of my numbers expressed in engineering mode. So we have 3.2K. So now I have 3.2. My exponent is going to be 10 to the third power. I know that. So I have 28 volts divided by 3.2 k ohms. And guess what? Hey, that didn't turn out right, guys. I wonder why. Oh, that's because, guys, we didn't go in and set up our calculator. All right, not trying to confuse anybody. So we'll clear this out now. I'll tell you what, we'll leave it right there, show you the difference. So we'll hit mode on our calculator. Right now it's in normal. So even though we hit that, the calculator said you want your number expressed in normal. Actually, no, Mr. Calculator, Mr. TI-83, we want our numbers expressed in engineering. So we push him over there to the engineering. We push enter, and guess what? Now he's set. Now we're gonna leave our decimal. We're gonna leave it floating, okay? And we don't want radians. We want degrees. So we'll use our arrow key and come down to radians. We will select degrees, and we will select enter once again. Now to get rid of this, to get back to our normal screen, we just hit clear. Now I want you guys to see what happened. Here's how it expressed our number, decimal 00875. I have no idea what that is. I don't have time to calculate that. But when I hit enter again, I get 8.75 milli. 28 volts divided by 3.2 k ohms will give me 8.75 milliamps of current. Okay. Now, here's what we're going to do. Let's come over here and let's go ahead and account for our current value. And our current value was 8.75 milli. Okay. So I'm going to come over here and say 8.75. Lowercase, we'll go ahead and spell them all the way out. 8.75 milli. Okay, that's not going anywhere. Now let's get my calculator back. Now, as I'm sitting there and I'm doing my problems, I'm not warm and fuzzy on this. I want to make sure that my calculator's not trying to trip me up. So, according to George Simon Ohm, all I have to do is go up here and thereby eliminate my voltage, put my thumb over that voltage, and I got my formula. This resistance of 3.2 k ohms multiplied by this current value of 8.75 milli should net me 28 volts. Okay, let's go ahead and let's try that. Now, word of caution. When we are using these powers of 10, our calculator is going to give us exactly what we asked for. So we have to be careful what we ask our calculator for. Now, we've heard in general class, PEMDAS, please excuse my dear Aunt Sally. We have to put our numbers in our calculator the same way, observing our order of operations. So what we're going to do, we're going to open up a parenthesis. We'll say 3.2 second, putting us in engineering function. Hit that E up there, and I know that 3.2 k ohm corresponds to a positive power of 10 for 3. And I'm going to multiply that by 8.75 milli. So we'll say 8.75 second function. Okay. Now I'm not going to hit this negative sign. The subtraction sign. I'm not going to do that. I am going to hit this negative sign. Yeah, that wasn't, no. Okay, that's okay. That's what happened when we're doing live TV, guys. We'll go back. Won't take but a second. 3.2 K multiplied by 8.75 second function. Double E for engineering mode. -3, because that corresponds to milli. Close that parenthesis. And look, we got our 28 volts back. And guys, it works like this for any of these. Even for the power, all the way through chapter 3, they always gave you 2 variables that you can use, okay? The voltage is on top, resistance and current are side by side. If you want to draw yours out and put the current over here where the resistance is, that's fine. Because multiplication, it doesn't matter, okay? All right, so let's get rid of this. See if I can erase this without interfering with my power wheel. All right, we've erased that. Okay, now I got our calculator back. Let's clear our calculator out. Guys, let's use, tell you what, let's use resistance and voltage this time. No, we did it already. Let's use current and voltage this time to come up with a resistor value. All right, so for my current value, let's say we have approximately 122 volts. Big volts. Sorry about that, George Simon Ohm. All right. So, and let's come down and let's have a modest current value of, let's say 12 micro. Ooh, yeah, 12 micro. Big amps, right? There we go. Okay. Now, get our calculator back. Guys, what's our formula? If we are looking for resistance, we're going to put our thumb, a piece of toast, or cracker. We're going to put something over this resistance value, thereby covering it up. And the only thing left will be our formula, voltage divided by current. So, let's try it. 122 volts divided by 12. Second engineering function, and I know that micro is 10 to the -6 power. So guys, I have 10.16 mega ohms. All right, let's come down here. Let's keep up with that. 10.16 mega ohms. Separate that. All right. Now, that's a whole lot of resistance, but that's okay. It's for demonstrative purposes only. Let's get that calculator back. All right. If you say, man, that's a whole bunch of resistance right there, is that correct? Yeah, let's go ahead and verify. This time what we'll do, we'll take our known voltage value, we'll manipulate that against our resistance value that we just found, and guys, we should come up with 12 microamps. All right. So again, formula is 122 divided by 10.16. Second, double E, engineering, and I know that's going to be a positive power of 10 in the sixth form, right? So let's see if we come out right. There it is. Okay, so for those of you who are wondering, all you need to do, since we have our calculator in floating decimal, all you have to do is account for 2 places behind the decimal point and you'll be fine. If you want to put this whole thing in there, guys, that's fine. My number going to be just a little bit different from yours, but it's fine. Now, I will caution you, if you are the type of person who wants to round, I don't care. Only thing I ask is that you round the whole way through. Don't get lazy halfway through and stop rounding because your number's going to be different from mine. Okay? So, there we have it, guys. Any of these 3, if you have 2 of them, you can come up with the other one. Trust me. Voltage always lives on top. Resistance goes down here, and we multiply resistance by our current. If you want to put the current over here, that's fine. If you want to put the resistance over here, only thing that matters is voltage is on top. That voltage has to be on top. Now, let's say, for example, let's do one more. Let's do our 12 microamps, or our 12 microamps, and let's multiply him by 10.16 mega ohms. Okay. Open up the parentheses. 12, second double E, -6 for micro, multiplied by my 10.16, second double E, 6 for the mega, and close that parenthesis. And just like that, 121.92 or 122 volts. Okay. Now, if you guys thought that I had you write the 250 powers of 10 just as busy work, or because I didn't like you or otherwise wanted to punish you, hopefully now you see why that is so important. When we start working with these circuits, I need you to know your powers of 10. I need it to be instinctive. I need you to know your micro. I need you to know your milli. I need you to know your nano and your pico, because we don't have time to stop and look at a cheat sheet or to look up in the air and chew on the end of our pencil and try to figure out what in the world that -3 represents. We already know that that's milli. Let's put that in that calculator and let's move on. Okay? If you are not to that point, you need to dedicate some time to where you understand these. You have committed these to memory, and you can manipulate both the negative and positive side of that power of 10 without fail. Okay? Remember, guys, we are building a tower of success. And that tower of success has a building block. It has a solid foundation. Okay? And things like this, okay? Things like this, those are the cornerstones. That's what's going to make our foundation solid. We don't need to get 45, 50 stories in the air to find this thing is not solid, because it's going to come crashing down right on top of us. And it's going to be our fault for using faulty materials in our building plan. Our basic building blocks have to be rock solid, okay? If they are not, now is the time to make sure that they are. Okay, so we're about 13 and a half minutes in. If you got something out of this video, that's good. You can go back and rewind it. If I went to the calculator too fast, go back, and for you guys who have this, go back and bounce your numbers off the worksheet using the calculator. Okay, and one more thing before I go, because I know I got one student who loves to do this exclusively, and I just want to prove a point here. The reason why we are forced to tell our calculator we want our number expressed in engineering form by selecting this double E, I want you guys to see what happens when I take a simple number like 1.8 kilo and raise him to the third power. I don't know what that number is, and neither do you. If you are in the habit of using this to get your power to 10, stop it. Don't do that anymore. Okay? Don't do that anymore. The only correct way is 1.6. Hit that second button, which is going to expose that double E, the engineering that lives right on top of the number 7. Okay? Double E, and I know kilo is a positive power of 10, and there it is right there. Okay? Now, for my people with the TI 30 Roman numeral 2 XS, your calculator is similar. Your mode functions work the same way. Your double E or your engineering button lives right on the top of the number 7. Second button, double E, put your power 10 in there. Okay? 369. Alright? That's it. Okay, guys. That's going to do it for this video. Hopefully you got something out of it, and you guys have a good rest of the day.